Today we're going to be doing lesson 9 from module 3, where we're going to continue adding fractions, but now we're going to be doing it numerically, which means without models, number lines, or pictures. We're just going to use our understanding of our math patterns to find like units or find common denominators and add our numbers together. So if we look at this first problem, which is 1a, the question is 3/5 plus 1/3, and we need to figure out what that equals. Well, previously, if we had approached this problem, we would spend some time drawing our models. We would draw 3/5, we would draw 1/3, we would find our new equivalent fractions that have like units, which just means common denominators, and then we would add them together. So we would do all that work, and we would get our final answer. But we've become aware of some patterns that can shorten this process for us. We don't have to draw the models to find common denominators because we learned how we can predict them by looking at the current denominators that we have. We know that 3/5 plus 1/3 is going to be added together, and to do that we need to have a common denominator. And if we thought about 3/5, we can picture that rectangular fraction model in our head and picture how we would have 3/5 and we would then divide it into thirds, right? If we had 3/5, we would then divide it into thirds to create our common denominator. And we learned how really that new denominator is just the two denominators that we're adding together multiplied together. So I know that fifths split into thirds is really 5 times 3, and 5 times 3 is 15. So I know that my new denominators are going to be 15 because 5 times 3 is 15. So to find my new numerators, I need to think about that. So 5 times 3 is 15. So that means I need to multiply my numerator also by 3 because I don't want to change the value of my number. I just want to multiply it by something equal to 1. And 3/3 is equal to 1. 3 over 3 is 1. So I can multiply 3/5 by 3/3 and not change the value of that fraction. Just make it have bigger numbers. So 3 times 3 is 9, so my numerator is going to be 9, and 5 times 3 is 15, so my denominator is 15. Now when I look at my 1/3, I did 3 times 5 to equal 15, so that means I need to do 1 times 5 to equal 5. So my new equivalent fractions that now have like units are 9/15 and 5/15. And now because they have common denominator, I can just add them together straight across. The denominator stays the same at 15, but my numerator becomes 9 plus 5. 9 plus 5 is 14. So my answer is 14/15. So all I did was to find my common denominator is I multiplied my current denominators together, 5 and 3, and then I made sure to treat the numerators the same way. You have to remember you're multiplying the numerator and the denominator to create your equivalent fractions. Otherwise, you're changing the value. Let's practice. 5/6 plus 1 and 1/4. So looking at this problem, I see a denominator of 6 and I see a denominator of 4. So 6 times 4 is going to give me my common denominator. And how I want to rewrite this problem. Well, 6 times 4 is 24. Notice how I'm keeping the 1 the same. I'm not affecting my 1 here at all. I'm just changing the fraction denominator. So I know my new denominator is going to be 24 because 6 times 4, my denominators times each other, equals 24. Now, I need to treat my numerators the same. So 6 times 4 was 24. So I have to do 5 times 4. 4 times 6 is 24. So I need to do 1 times 6. Now I can rewrite my fractions completely. 5 times 4 is 20. 6 times 4 is 24. So that's my first fraction. The 1 stays the same. Now I'm going to do 1 times 6 is 6. 4 times 6 is 24. So my new equivalent fractions with common denominators are 20 24ths plus 1 and 6 24ths. And now I can add them straight across. It's going to equal 1 and 26 24ths. Because all I do is I add my whole numbers together and then I add my fractions together. And because there's only one whole number, it just stays that one whole number. The problem I have now is 26 is bigger than 24. So it's an unhappy fraction. I need to simplify this and make it into a proper fraction where the numerator is less than the denominator. Some of you guys might be able to see that you can take out 24 24ths, which equals 1. And that leaves me with 2 24ths. Or you might prefer to write it as a division equation where you're doing 26 divided by 24. And you'll get the same answer here, where you get 1 and 2 24ths. So you have to then combine that 1 with your 1 whole you already have. So now you have 2 and 2 24ths. You're not completely done yet because I can still simplify my 2 24ths because they're both divisible by 2. So when I divide it by 2, I get 2 and 1 12th. And so my final answer is 2 and 1 12th. Let's try it with a word problem now. Mrs. Howe bought a bag of rice for dinner. She used 3/5 kilograms of the rice and still had 2 1/4 kilograms left. How heavy was the bag of rice that Mrs. Howe bought? So let's identify our important information. We know she bought a bag of rice. She used 3/5 of the rice, and then she still had 2/4 of it left. So if I draw that out, if this represents my one bag of rice, right? We don't know how much that is, whatever the bag is. We know that she used 3/5. And she had left 2 1/4. Now the question was, how heavy was the bag that she bought? So they want to know this bag. They want to know what the total weight of the bag was that she bought originally. So looking at this, this is an addition problem because I can add my pieces together to give me the full weight of the bag. So what I'm going to be doing is I'm going to do 2 1/4 plus 3/5. And I can think of that as 2 plus 1/4 plus 3/5. And because I have these two fractions now, I need to find common denominators for them. Well, I can see 4 and 5, and 4 times 5 is 20. So a common denominator that I can use is 20ths. But I need to change my numerators. I need to make sure that they match. So 4 times what is 20? Well, 4 times 5 is 20. So I'm going to do 1 times 5. And 5 times what is 20? Well, that's 4. 5 times 4 is 20. So then I'm going to do 3 times 4. So 3 times 4 is 12 20ths. And 1 times 5 is 5 20ths. So my new equation is going to be 2 plus 5 20ths plus 12 20ths. And then I can add my fraction pieces together to give me 17 20ths plus 2. So then I can just merge those and say it's 2 and 17 20ths. And if I look at 17 20ths, there's no simplifying that needs to be done because 17 is prime and it cannot evenly go into 20. So I can say that the bag of rice was 2 and 17 20ths kilograms originally. That was the weight of the rice. So when we're adding fractions, we can solve it numerically by looking at the denominators of our pieces and timesing them together to find our new common denominator. Once you do that, you then can find your new numerators and then add it straight across. This is a strategy that you can use instead of drawing rectangular fraction models as an option. I want you to practice this one today. If you prefer to draw models or do number line, that's okay. But I do want you to be aware of all the different styles that you can use when we're adding and then later subtracting fractions as well. And we're going to be continuing this numerical process.